This is part 2 of our lesson on rational functions and asymptotes. So the question that we're working on says for each of the following, state the vertical, horizontal, and oblique asymptotes. So our previous investigation on intercepts and asymptotes, we looked at how to find vertical asymptotes, and then we worked on how to identify from an equation whether you were going to have a horizontal asymptote or an oblique asymptote. So we learned that vertical asymptotes come from the values that make our denominator 0. But I can also tell where they are on the graph by just looking at the graph. So I think that's what we're going to do. So if I look at my first graph here, I have y equals 1 over x plus 1. So there is a vertical asymptote at -1. So I know it's a vertical asymptote because there's a break in the graph, kind of in the middle of the graph, right, where one end is pointing in one direction and one end is pointing in the other. So my vertical asymptote is passing through the x-axis at -1. So this would be x equals -1. This is also the value that would make my denominator equal 0. -1 plus 1 would give me 0. You cannot divide by 0, which is why we're getting an asymptote. Let's do all the vertical asymptotes first, and then we'll do the horizontal and oblique. So if I look at my next one, I see the two ends in the middle. So I'm going to say that there is a vertical asymptote at -1 again. And you'll notice it's the same denominator, so it makes sense that it would be the same asymptote. So my vertical asymptote once again is at x equals -1. If I look at my third graph, once again, I have x plus 1 in the denominator, so I should have an asymptote at -1. So there's going to be 1 at x equals -1. And then this last one, you'll notice it's a different denominator. This time it's x squared plus 2x plus 1. It's a little harder to tell from this one where the vertical asymptote is because I'm only showing you the graph from like 10 to -12. So if I had zoomed out more and shown you more of the graph, you would see that the asymptote is at -1. How do I know that it's at -1? Because it is hard to tell based on what we can see on the graph. Well, x squared plus 2x plus 1, if I factor that, two numbers that multiply to 1 and add to 2 would be 1 and 1. So this is x plus 1 times x plus 1, or x plus 1 squared. So in the denominator, it's x plus 1 squared. So I know that it's going to be at -1. And we talked in the previous lesson about how a square means that the two ends are going to be going in the same direction. Whereas you'll notice on all the other graphs that the ends on the opposite sides of the asymptote are pointing in different directions. And anytime there's a square, they're going in the same direction. So asymptote on this one is also x equals -1. Okay, horizontal and oblique. If I take a look at the first graph and I look at the ends as it goes to -infinity and +infinity, that's how we find our horizontal and oblique asymptotes. I notice that this end is leveling off at 0, this end is leveling off at 0, so there is a horizontal asymptote at 0. Now this one is crossing through the y-axis at 0, so it is y equals 0, and it is horizontal. It is not oblique. You will only ever have one or the other. So since I have a horizontal, I do not have an oblique. If I look at the next one, I look at this end. This end is leveling off at 2. This end is leveling off at a y value of 2. So I think there is a horizontal asymptote at y equals 2. If there's a horizontal asymptote, that means there is no oblique asymptote. If I look at the next one, This end is going to negative infinity. This end is going to positive infinity. So I think this is going to be oblique. Now, obliques are a little tricky to draw. It depends on how much of the graph I can see. What I'm going to try to do is line my ruler up with the two ends and then try to draw a line in. I'm not necessarily connecting the two ends, but that's kind of what I'm doing when I'm drawing that in. Okay, so it is not horizontal. It is oblique, and I need to come up with the equation. So this is why we reviewed the equation of a line. So when I'm doing equation of a line, I need the y-intercept and the slope. So I'm going to start with the y-intercept, and then I'm going to do the slope. So for the y-intercept, it's tricky because the line I drew is not perfect, but it appears to me that the y-intercept is -1. So I'm going to say the y-intercept is -1. And then for the slope, I'm going to try to follow the line and see how do I get from one point to the next. So it looks to me like the next point is here, which means I would be going up 1 over 1. And then I'm going to check to see, am I still on the line if I do that again? So up 1 over 1, well, that worked. Up 1 over 1, we're still on the line. Up 1 over 1, I'm still on the line. So I feel good in saying that the slope is up 1 over 1 or 1 over 1, which is the same thing as just 1. So my equation is going to be y equals mx plus b, so 1x and then plus b, or in this case, -1. Okay, if we look at our last one, I'm looking at the ends of my graph. This end here looks like it's crossed 6. It's heading towards maybe 5. On this side here, it looks like it's hit about 4. So I'm going to say I think the horizontal asymptote, sorry that I turned my page, is at 5. To be sure, we would really need to zoom out so that we can see a little bit more of the graph. If I could see more of the graph, you would definitely see that it is leveling off at 5. This is a horizontal asymptote, so I'm going to say that this is y equals 5. So why didn't I think that was oblique, right? This, to me, appears that it has crossed 6, and this one is kind of at 4. I don't think it would just be a line connecting 6 and 4. Right? They really, I think, are approaching 5. I can also show you algebraically how we know that that's true. So one of the things that we talked about when we did our investigation, the previous one, was how you can tell if something is going to have a horizontal or an oblique asymptote. And we said if you look at the degree of the numerator and the degree of the denominator, if the degree of the numerator is higher, it's oblique. And if the degree of the denominator is higher, then it's going to be horizontal, or if they're the same, it's horizontal. So the only time we get an oblique asymptote is if the degree of the numerator is bigger. So this would be a degree of 0. This would be a degree of 1. So the top is not bigger, which makes it horizontal. This one here, they both have a degree of 1, so that would make it horizontal. This one here, the degree on the top is bigger. It's squared than the bottom, which is just an x. So this one is oblique. And then this one here is x squared and x squared. It's the same degree, which means it is going to be horizontal, right? In order for it to be an oblique asymptote, the degree on the top has to be bigger. So that's how I knew that it had to be horizontal. Okay, we are just going to take one more second to talk about something we mentioned in the investigation before this. One of the ways that you can find the horizontal or the oblique asymptote is to divide your denominator into your numerator. How many times does x go into 1? Well, it doesn't. It goes in 0 times, which is why this is at 0. How many times does x go into 2x? Well, it goes in twice, which is why this is at 2, right? For this one, how many times does x squared go into 5x squared? it would go in 5 times, which is why this is at 5. For this one, if you actually performed the long division between these two, you would get your equation. So in order to find horizontal and oblique asymptotes, right, you can compare the degrees, you can look at your graph, or, as we're going to discover in some examples to come, you can do some long division. So I will join you in the next video for the next part of the lesson.